Together with me today, we have teacher Hashini. Right, so we'll be leading this science set 1 Jumpstart workshop. Are all of you ready? I hope all of you have your materials with you. Good morning. Anybody there? Hello. Hi. Thanks for responding. Right. So I'm teacher Mingyi. Right, and we have teacher Hashini. Today we'll go through the science part with all of you. I believe most of you would have attended the other subjects as well. Hi. Hello. Hold on. Yes. Okay. Good morning. I hope you all have your breakfast. Okay. Otherwise, it's okay. You can go and have your breakfast in front of the screen, right? Because we can't see you. Okay. In case you're not familiar with webinars, right? So we can't see you. Sorry, but you can see us. Okay. Right. So can I just see a show of hand? How many of you were with us since P6? Okay, you should have seen me in the P6 Power Up, P6 last lab. How many of you? Okay, a number of you. Great. So this should not be unfamiliar. Thanks for raising your hands. Right. Does anyone not have your materials with you? Now, it's great that all of you joined this session, right? Because this is a jump start, right? I know it's still school holidays, and sadly, Christmas is coming, but also means the new year is starting. But I don't want to spoil the mood here, okay? But since you all have joined, so let's make full use of this session. Right, it's just going to be a 2.5 session. So we'll give you some brief introduction of some of the topics that you will learn in Sec 1. Yes, mostly Sec 1, yeah. Okay. If you have not gotten your worksheet, please go and get it from your bag, from your file, whichever. Okay, if you did not print it out already, now the link has already been uploaded into the chat. Okay, so you can download it. All right. Now, so since we have quite a number of you already, then I think we can get started. Okay, maybe before we get started, maybe teacher Hashini, you want to say something to the crowd here?
Hi everyone. I know it's hard, 9:30. You're here to study science. Thank you so much for coming, and I hope all of you all have fun. Okay, if any questions, please feel free to drop it in the chat box as well. Okay?
Yeah, so since you all are considered still P6, right? So keep your primary level of noise and responses high in the chats. Okay, so if any question as we go through later, right, just ask us in the chat or put in the Q&A. All right. Okay, so let me share my screen. Hmm. Now, how many of you have already started, looking through the materials here? Nobody? Okay, how many of okay, we have a few. Great. Good. Good job. Now it's important to start early. Okay, I know you are still in the holiday mood. Okay, but you start early. That's why you have the head start. Okay, you have the head start. And then when you learn it in school next time, you'll be a brisk because you have already learned some of this. You have an idea what it is already. Okay? So some of you might have already, went to read a lot more. And some of this, like the periodic table, is nothing new to you. All right, how many of you are familiar with periodic table? Okay, 4 to 5 of you. Great. I see the future chemist in you guys. Okay. Good. Right. For myself and teacher Hashini, we both studied chemistry. So periodic table is like our what's that called? It's like what we always have in our hands.
The Holy Grail.
or the Holy Grail. Yeah. I definitely did not buy a cup with a periodic table. I definitely did not. Okay. All right. So today we'll be going through science. All right. So these are the topics that we'll cover. First thing, we'll cover the scientific skills, the basic scientific skills that scientists use. All right, that will be the first thing that you'll learn in Site 1. Some of the basic things, okay? And we'll talk about some chemistry, periodic table, elements, compounds, mixtures, separation techniques, density. Some of you should have heard about density. Okay, you should know what density is roughly, or have an idea about that, what's that. And then reflection and refraction of light. Okay, there's a difference between these two terms. Huh? So this is a topic of light. So part chemistry, part physics. Okay, physics will be the second half. All right. Okay, I think we can get started. All right. Now, first thing. Now, so when we learn science, okay, just like in primary level, actually some of these skills you have already learned. Okay, you have learned about all the experiment-based questions and how to answer them. So things like what's the aim of the experiment, what's the hypothesis, what's the conclusion, what is the control setup, fair test, all this you have learned how to answer them for the PSLE. Okay, and I hope you have learned it well. Okay, when you come to secondary, that will continue. Okay, and you will also learn this scientific method. So this scientific method is what we call a systematic approach to answer questions about the world around us. So let's say we have a question. Then what do we do? How do we answer it scientifically? All right. So let's say, for example, I have this question. Okay, you want to grow a plant. You are growing a plant and you want to find out, okay, whether this fertilizer makes the plants grow taller. So you ask this question. Maybe you ask your parents, you want to grow this whatever plant that is, and then you find out whether you want to add one fertilizer and want to find out whether it helps the plant to grow taller. All right. So you make some observation based on some research or some information that you have gotten from your parents. Okay, you roughly know that fertilizers generally will allow plants to grow taller. But sometimes, the fertilizers may not apply to all plants. It may not work for all plants. Or maybe there's a specific fertilizer that works for a particular plant. Okay, so these are information that you can gather. Right, so you can make a hypothesis. Now we are at step 3, yeah? You make a hypothesis. Now you should already know what hypothesis is tested for PSLE. So hypothesis is an educated guess or prediction of your experiment. Okay, let's say for example, okay, you make a hypothesis. If I add the fertilizer, then the plant will grow taller. That is your hypothesis. So with this hypothesis, you go on to test whether your hypothesis is true or not. Okay? Or you could make a different hypothesis. You can your hypothesis can be if I add the fertilizer, okay, then the plant will not grow taller. So that is like a negative hypothesis, but it doesn't mean it's wrong. Okay, a hypothesis is supposed to be a guess, a prediction. Okay, then you test with your experiment and see whether your result, okay, aligns with the hypothesis, whether it agrees with the hypothesis. Okay, so you conduct a fair test. Now, when you conduct your test, your experiment, always remember we must ensure a fair test, which means that there should be only one changed variable. Okay, I still use change variable because since you are still going to set 1, right? But later, there's a different term which I will tell you in a while. Okay, there should only be one change variable in a fair experiment, a fair test. So during your experiment, you must make sure you have all the variables listed out. What is your change variable? What is your measured variable? And what are those variables that you want to keep the same? Okay, let me see some comments. A hypothesis is temporary. Uh, I won't say it's temporary. In a way it is, but it's not exactly the same meaning. Hypothesis is like uh, you are guessing the results. So it's not that it's temporary. Temporary means that it's there and later it's not there. It's not in that sense lah. Okay? Hypothesis is like you're trying to guess something and maybe it's true, maybe it's not true. That's not the same as that's not the same as a temporary. Right? So that's why coming back to this situation, right? So if I use a fertilizer, maybe the plant will grow taller, maybe the plant will not, maybe the plant will die. So these are different hypotheses that we can make. And then we do the experiment to test that. Okay? Yeah, it's a guess. Okay? All right. So once we have our result, okay, then we use all the results, we're going to find out the trend, going to find out the pattern, whether it really leads to what your hypothesis is saying. Okay, so you compare the conclusion of your results and the hypothesis. All right, so if your results supports the hypothesis, okay, then you repeat your experiment to make sure you can get consistent results. Okay, and if you really can get consistent result, that means that okay, your hypothesis can be supported, then this hypothesis could be a new scientific theory or law. Okay, but if let's say the hypothesis is not supported, somehow your conclusion and the hypothesis are totally opposite. Okay, like for example, you said the fertilizer causes the plant to die, but it's not true, then your hypothesis is wrong. So you need to modify and then return to step three. You jump back. Like snake and ladder, just jump back. Okay, you jump back to step three, come up with a new hypothesis or modify your hypothesis, then repeat again. Do the experiment and repeat. Okay? So this is the scientific method, and this is the standard that has been used in the scientific community. All right. Now, let me talk about the variables. Variables you are very familiar. Okay, just that when it comes to secondary level, we no longer call them the change variable, the measured variable. Okay, I mean they are still correct, just that it's more commonly used. Independent variable, dependent variable, they are more commonly used in in secondary level. Okay, so be familiar with these two other terms. So change variable is the one that you change, and that is the independent variable. Okay, measured variable is the variable that you measure. And this measured variable is called the dependent variable. Why is it called dependent variable? Because it depends on the change variable. Okay, whatever variable has been changed, it will result in it will cause changes in your experimental results, and that is your dependent variable. It depends on your independent variable. Okay, and controlled variable, this is also called constant variable. It's also called constant variable. This one's still the same, constant variable, control variable, basically the variables that are kept the same. Okay, so this one you should not have an issue with this. Any questions so far? Please put in the chat. Okay. All right. Now let's try this question. I want to see all of your responses. Can you think about this and put your answers in the chat so that we know whether you know this well enough or not. Okay, you can read the question. The question is a very short one, just from the sentence. Determine what is the independent variable, dependent variable, and one of the controlled variable. Put all three answers, please. Put all three answers, and you want to put A, B, C also can. Independent variable is A, dependent variable is B, and C is controlled variable. Okay, please try. I'm sure you already know this, but just be very careful. Hmm. Okay, if you need to double check what independent variable is, dependent variable is, okay, just look at the top here. Independent variable is the changed one. Dependent variable is the measured variable. Hmm. Hmm. Okay, I'm seeing a lot of responses coming in. Keep it up. Keep going. Okay, now I just want to mention one thing is that for dependence variable, okay, great, I see one correct answer. For dependent variable, right, usually is the variable that you want to measure during the experiment. So rate is something that you can't really measure. Okay, so I just wait for a few more responses, then I explain in more detail. Very good. I see some correct answers for the dependent variable. Now, even though the question says rate, right? So I want you to think about this phrase. Rate of evaporation of water, that is like the concept, the scientific concept. But in an experiment, how do we determine the rate? What are we actually measuring? Yes, I see some correct answers. Hmm, hmm. Very good. Thanks for all your responses, huh? All right, so I think we can go through already. Yes, amount of water left, surface area of water. Surface area of water means you keep the container the same. Okay. Yes, amount of water left. All right. Now, so what we have here, great. It's good that all of you are trying. All right. So you look at the independent variable. So again, this is the changed variable. Okay, dependent variable is a measured variable. Now, so this is the aim, right? This is the aim of the experiment. The aim of the experiment is to investigate how temperature of water affects the rate of evaporation of water. Okay, this is something new, right? But when it comes to specific measured variable, okay, that will be slightly different. Okay, but I'll talk about the independent variable first. So that is the temperature of water. So this is what is being changed. All right, so this is temperature of water. Okay, there's only one for a fair test. So most of you got it correct. Okay, got it right. Now, then the second one, what is being measured? So just now I mentioned, okay, so the scientific concept is that we are finding how temperature of water affects the rate of evaporation of water. But rate is how fast water evaporates. How fast water evaporates. How do we measure that in the experiment? What are we measuring? So I saw some answers. Okay, let me scroll up. Okay, correct. Okay, I saw one. Amount, or you can say volume. It's better to be volume. Okay, let me just put volume. Okay, when we come to secondary level, let's be more specific. Volume is volume, mass is mass. Okay, amount is too general. So volume of water left after a fixed amount of time. So this is one possible answer for the measured variable or the dependent variable. Okay, volume of water left after a fixed amount of time. So this is something you can measure. We we fix the time, right? Time is the controlled variable in this case. Okay, so in this case, I can keep it as duration of experiment. So after a fixed amount of time, right? So it could be maybe 2 hours. So I fix that 2 hours. Okay, then I come back and check how much water is left. And the one with the less water that is left, then there's a faster rate of evaporation. Okay, so that is one possible answer. Okay, yes. So one of you is asking, can I write time taken for the water to fully evaporate? Correct. Okay, so there is an alternative answer. So let me use another color. So this is a second answer. So this is answer one, answer two. Time taken for all the water to evaporate. Okay, which is the same as what Fiona you have mentioned. Okay, so time taken for all the water to evaporate. So now, if my answer is number two, if my answer is number two, then I am not fixing the duration. Now, do take note, right? If I keep the duration of experiment the same, then that is only for number one. Okay. If your measured variable is number two, okay, then duration is not kept the same. Okay, duration is not kept the same if your measured variable is number two, because number two is time taken. We are measuring the time for all the water to evaporate. Okay, so in this case, number two, we can have all the other variables that we want to keep the same. So maybe, for example, initial volume of water. So that must be kept the same. Okay. Yes, Oli, yeah, correct. Amount of water at the beginning of experiment in each setup. So that is my number two here. Of course, there can be many other controlled variables. Okay, like for example, temperature of the surroundings, exposed surface area of the water, size of the container, presence of wind. All these that affect the rate of evaporation. All those can be kept the same. Okay, we have many answers. So yeah, I think I mentioned most of the ones that all of you have mentioned. Yes, amount of water used, exposed surface area. Yeah, yeah. So I think most of you, okay, location, right? Right. Location is correct, but it's not specific enough. So in terms of location, you can mention the factors, like for example, temperature of surroundings, humidity. Those are the factors in that same location. So can be a little bit specific other than the location. All right, so I've just written two answers. Okay, maybe I add on. Hold on. Okay. So it could also be humidity. You all have roughly learned about humidity, right? Humidity refers to the amount of water vapor in the air. And that is the fourth factor that affects the rate of evaporation of water. Okay, not in PSLE syllabus, but maybe you all have learned this. Right, and of course the other factor that affect rate of evaporation, presence of wind or strength of wind also can. So these are all possible answers. Okay, exposed surface area. Exposed surface area of the water. All right, so all these must be kept the same. Okay, any questions? Yeah, thanks. Teacher Ashini has put the answer in the chat. Anyone else wants to clarify anything? Okay, let's say that for location, be a bit more specific. What is in the location? The temperature of the surroundings, you can keep that the same also. Uh, Humidity, presence of wind, is there wind in that location? Yeah, so location is a bit too vague, so we can be more specific on that. Okay, if no questions, then I will move on. Right, let's move on to chemistry. Right, so for your periodic table, you all know what is a periodic table? Okay, if you all flip to the back of your worksheet or scroll to the end, right? So you will see the periodic table. So let me show you. And this is not in the right orientation. Okay, let me find the one that is in the correct orientation. Hold on, let me see. Oops, still not. Oh, I think I can flip this. Okay, yes, I can flip it. All right, so this is a periodic table of elements. Okay, so I'll explain to you what are elements. So basically, if you look at this, each of them have a particular number. Okay, there's a lot of information here, and in when you go to secondary level, you will learn some of these elements. Okay, don't worry, you do not need to know all 118. Okay, there are 118 elements currently. Okay, actually, quite a number of them are quite recent. So you see all these later number ones, okay, 111 onwards, all these are quite new, newly discovered or newly synthesized elements. Okay, okay. So there are 118 of them. But uh, to be honest, when we finish, like let's say O-level exam or the Sec 4 exam, okay, you will only know maybe like 30 out of these 118. Okay, so not to worry. Okay, not to worry that you have this whole periodic table. Okay, you don't need to know all of them. It's impossible unless you are super genius. Okay, so no need to worry about that. Okay, so for this periodic table, how are we going to use it? Now let's talk about the elements first. So what are all these elements? Huh? Okay, now you have learned about matter. Matter is basically anything that has mass and occupies space, right? That's matter. You learn it in P4. Okay. Now, but matter in the simplest form is called an element. Okay. I give you some example. An example of an element is like iron. Okay. An iron is a pure substance. You cannot break down iron into anything that is simpler, even using chemical methods. You can break it into smaller pieces. Can you use a hammer hard enough to break the iron? Yes, you can break it into smaller pieces. But what I mean is chemically, iron is really the most basic. You cannot change iron into something even simpler than iron. So that's what it means by element. Okay? And what we have in the periodic table are all elements. So 118 of them. Yes. Okay, so all these elements, they are represented by a chemical symbol. Right. Can anyone tell me what is the chemical symbol for iron? See who's the fastest. Since I'm talking about iron, right? Okay, I have all these hydrogen, calcium, and so on. What is iron? See who can find it first. Okay, better not be teacher Hashini answering the question, huh? Oh, I have a first response. Very good. Okay, is your name Hui Cheng? Hui Cheng? I think that is your name. Yes, why got IO2 ah? No, no, it's not IO2. I don't know where IO2 come from. FE. FE. Correct. FE. Very good. Oh, you're very fast. Okay, so FE. Now, if you see, right, when we write the chemical symbol for iron, first letter is capital, second letter is a small letter. Okay, same for calcium, same for sodium. Okay, so just now I saw someone write this FE capital. Maybe you just accidentally press it. Okay, but this is not correct. This is correct. Okay, there's a reason. We only put it capital for the first letter of an element. If we put two of them as uppercase, then that will represent two different elements. Okay, so one element is F, one element is E. I don't know whether it's an element that is E, but I know there's F. Okay, but if we put it this way, that means that there are two different elements. So that is wrong. Okay, so second letter should be a small letter. Right? Now, so some of these names, right, you see they don't tally, like sodium. Why is sodium Na? Why is sodium Na and not maybe S or maybe SO? So this is a common mistake, right? Many students will write sodium as S, but S is for sulfur, another element. Now, can anyone tell me why the elements like sodium, it doesn't follow the name sodium? All these are wrong, don't copy them, Okay. Can anyone explain to me why sodium is not SO? Why is it Na? You're faster go and Google the answer for me. Nobody knows? Okay, maybe I just briefly explain to you. Okay, not in great detail. Okay, because now we learn it in English, but actually some of these elements, when they are invented in a certain country. Let's say maybe Germany, Latin. So some of these names are in Latin. Some of them are in different countries which uses different languages. Okay, so when they are first created, okay, then their symbols will follow that. So for sodium is actually called natrium, natrium, if I'm not wrong. That's why it follows Na. Okay, but no need to worry about that. Okay, that is not required of you to know that. Okay, so don't worry about that. So you just need to remember these symbols for these elements will do. Okay. All right. So these are just a few, right? So like I said, in secondary level, you need to know maybe up to 30. Minimally is 20. Then you should know slightly more than that. So that's around 30. All right. Now in your periodic table, the elements are split according to metals and non-metals. Later I'll show you where. So metals you should know. Sodium, aluminium, iron, all these are very common metals. And then we have non-metals, okay? Carbon, oxygen, sulfur. Now I'm not just talking about any non-metal. Okay, it's not like plastic, it's not this kind, it's not plastic, wood, rubber, it's not this kind, okay? Of course, there are also non-metals, but we are looking for elements. Okay, so these are not the ones that we are looking for because those are not elements. Okay, so in the periodic table, these are the elements which are non-metals. So let's talk about the periodic table. So in this periodic table, we look at you just take it as it's like a table. I mean, it is a table. So you look at the row, which is the rows are horizontal, right? Rows are horizontal, columns are vertical. Okay, so if you look at the vertical column, the one in red here, so we call it a group. So if you see here, 1, 2, 13, 14, 15, 16, 17, 18. These are group numbers. Okay, while period refers to the rows. So we have period 1, period 2, 1, 2, 3, 4, 5, 6, and so on. Okay, so let's say sodium, right? If I zoom this in, let's say sodium. Sodium will therefore be in group 1, but period 3. Okay, group 1, period 3, that is sodium. So it's like we can use the group number and period number to identify the elements. Or we can tell which group and which period an element is in the periodic table. Okay? Alright, so that is the group number and period number. Alright? Now, so just now I was talking about the metal and non-metals. Okay, so one of you mentioned that sodium is salt. No, no, no. Sodium is the metal, it's not salt. Salt is sodium chloride. Rishi, salt is sodium chloride, the one that we eat. But actually, salt is a very general term. Sodium chloride is a table salt. That's a common name for sodium chloride. So it's a salt that's edible, but salt is something that is it's a term that is very general, referring to many different things. Okay, which you will learn more in secondary level. Okay, now coming back to this. So do you all see this dividing line? There's this line here. Okay, let me use this. Okay, to tick. You all see that thick line there, right? Okay, the thick black line. So this is the dividing line that divides the periodic table partially. So those on the left side, they are the metals. Those on the right side, they are the non-metals. So these are the metals, and these are the non-metals. Okay? So that's one easy way to classify them. So let's say just now I go back to the top, right? Okay, non-metals, their elements include carbon, oxygen, sulfur. So if they ask you, okay, is this element a metal or non-metal? So you find in the periodic table. So carbon is here, oxygen is here, sulfur is here. They're all on the right side of this dividing line. So that makes them non-metals. Okay? Of course, there are a lot more information we can get from the periodic table. Okay, but now we are just giving you a brief idea how to make use of the periodic table. It's a simple part to differentiate them. Okay, so here we have the metals, non-metals divided by the dividing line. Now this dividing line is also called the Hayes-McDaniel line. Okay, but some of you learn this, most of you don't learn this, so no need to worry. All right. Now, one thing that I also want to mention, okay, which is mentioned here, elements on the left of the dividing line except hydrogen are metals. So hydrogen is in the middle here. It's an exception. Okay, it's an exception. So it's basically a non-metal, but it's placed on the left side. Okay, it's a non-metal. Right, that's an exception. Okay. Now, we're gonna have a quick revision. I mean, that's a quick quiz. After this, then we have an activity. Okay, so maybe you all spend some time. I give you all 2 minutes to complete this. Try this question. Write out the symbol for these elements. Nitrogen, chlorine. You can write the name of the element with the symbol K. Go and search for that. Tell me whether it's metal and non-metal. Tell me which group and which period it is in. Okay, so can you try that? Yeah, give you about 2-3 minutes to do that, huh? The periodic table is at the back of your material. Okay, you can scroll to the end or you can uh flip to the back if you're using a physical copy. And I'll go through with you in 3 minutes. Yes, of course you can refer. Yeah, it's a practice only. Okay, it's a practice. I'm not expecting you to know it in just that 10 minutes of going through. Okay, no, of course. Now, periodic table is something that is a paper, is a piece of information sheet that is given during the exam. That whenever you are tested on chemistry, and if you need the periodic table, it's always given. Okay, so not to worry, the periodic table is given in an exam. So don't think that you need to know all that 20, 30 elements that I told you. Yes, you need to know. It's best that you know them well, but the periodic table is given to you. Okay, so you do not need to like memorize everything. But after doing it for a while, then you should be less dependent on the periodic table. Oh, Carla, which part do you not understand, Carla? Okay, let me know which part that you are not confused. You are confused. I'm confused. The whole thing. Hmm. Okay, come. I do the first one with you guys in case you are. Okay, no worry. Okay, so some of you are. Okay, maybe I do the first one with you all. Then you all can try the second and third one. You've seen some of you are a little bit confused here, so not to worry. Now, symbol is something you can find in the periodic table. Okay, so we want to look for nitrogen. Okay, so let me go all the way down to the periodic table. Find nitrogen. So if you search, okay, nitrogen is found here. This is nitrogen. Okay, this is the nitrogen. So what is the symbol for nitrogen? N is the symbol. Okay, so you go back there, go back to the question, write N for nitrogen. Okay, then they ask you, okay, whether it's a metal or a non-metal. So just now, I mentioned to you this, right? Hold on, let me go back, flip this around. Okay, read this sentence for those who are confused here. So this sentence here, okay, says that a dividing line going across the periodic table separates the metals from the non-metals. Okay, those on the left of the dividing line are metals. Those on the right of the dividing line are non-metals. Okay, so let me zoom in on this nitrogen again. Okay, a little bit messy, yeah, so let me clear this up. So nitrogen is here. This is nitrogen. So is nitrogen on the right side or on the left side? Okay, nitrogen is on the right. So on the right side of the line of this zigzag staircase, okay, is a non-metal. All right. Kara, is that clearer now? At least for the symbol and whether it's metal and non-metal. Same for Natalie. Great. Okay. Then what's the next one? The next one is to identify whether it is identify the group and the period. So let's look at the table again. So the group number, okay, you see this here? Group. So all these numbers on top, they are the group number. Nitrogen is found here. So nitrogen is in which group, Kala? Nitrogen is in which group? If nitrogen is below this number 15? 15. Yes, great job, Kala. Okay, and Natalie, which period is nitrogen in? Okay, I go to the left side here. So you can see my screen. So period is the horizontal row. Okay, so the first row is this row with hydrogen and helium. So that is the row 1, and nitrogen is the second row. So which period is that? Yes, Natalie, that's 2. Well done. See, learn already. Not difficult, right? Okay, great. Thanks for all the answers on in the chat. Great. Josh, potassium spelled wrong. Potassium, not potassium. Potassium. T, that's a T. Okay, great. Good. Anyone else has question before I review the answer? Anyway, try the other two questions, Natalie and Carla. Try the other two. It will take a while for you all to be familiarized with the position of the elements. Of course, you'll not be that one snap, you know where they are. Okay, it takes a while. Oh, some of you are asking about the lanthanoid and the athenoid. Okay, don't worry about those. Okay, don't worry about this. Don't worry about all this below here. So I just put it in red here. Okay, this is lantanoid, this is antinoid, and these are the ones below here. Okay, don't need to worry about all this. It's just a name for these groups of elements. Okay, it's just a name for this group of elements. So those in this 57 to what's that? 57 to 71, those are called the lanthanoids, and then so on. They are just different names for this group of elements, but it's not within your you do not need to be too concerned about them. Is potassium a metal? Yes. Where is it located? Let me erase this. Potassium is found here. Potassium is here. Is on the very left side of the periodic table. So it has to be a metal. Okay, one of you is asking, okay, you're good, ask a lot of good questions. Okay, you have analyzed the whole periodic table and down here you see there's one Avogadro constant. Now, Avogadro is not avocado, Okay, avocado is a fruit. Avogadro is a person who invented this. Okay, so that it answers your question. So he came out with this value, but again, you no need to worry about that. You will learn more about this in Sec 3 a few years later. Okay. So just for Sec 1 and Sec 2, you will just only learn some of the very basic ones, the first 20 elements and maybe 30 elements, but not all the information is needed. Okay? Yes, K is potassium. Here. Potassium is here, right? K. Potassium is not P, Oh, but anyway, they give you K lah. The question give you K, so it's potassium. Okay, now I think we can review the answers already. I hope I didn't spend too much time. I will need time for the physics part. Okay, right. Okay, let's write the symbol first. So nitrogen is N, chlorine is Cl. Now the L, right, if you look at how it's written in the periodic table, is a little bit cursive. Let me show you. Uh, in your periodic table, the L here is very messy. Okay, Cl, the L is a little bit cursive L. So I tell you how you can write this. Okay, so for the cursive L, you write it like that. Okay, let me go back to the question. Cl, you can either write it like that, like the periodic table, or you can write it like this. I will prefer to write it like this, the one that is below. Okay, with this fish L. Okay, but either one works. Okay, and K is for potassium. I'm just gonna text it. Potassium. Where is it? Times New Roman. Okay. Zoom this in. Okay. Right. So identify whether it's a metal or non-metal. So for nitrogen and chlorine, where are they? Can you see that they're on the right side? Nitrogen and chlorine, they are both on the right side of the dividing line. So they are non-metals, while potassium is on the very left side of the periodic table. It must be a metal. Okay, so this is a metal. These are non-metal. Okay, so just like I went through nitrogen. Nitrogen is in group 15, period 2. So for chlorine, let's go through chlorine. Chlorine is in 17. You can see, right? It's right below 17. And take note, this is period 3, not 2. Okay, so period 3. 17 and 3. And for potassium, it is group 1, period 4. Okay? Group 1, period 4. Did you get it right? Clara, do you get it right? Is it Clara? Sorry. Carla? Natalie, do you get it right? Josh, good. Safwan, you all get it right? Well done, everyone. Okay, interestingly, we're gonna have a quick quiz, a fun quiz, Kahoot. I hope you all have your devices. Go get ready your devices. Ooh, we have a Kahoot. Wait, let me start it up. Cannot see the Kahoot, right? Okay, hold on. Wow, very fast, Easton. Wow, you're very fast, I only just did it like a few seconds ago only. Fastest finger. Okay, let's wait for another minute more. Okay, already? Still got a few of you have not joined. Okay, this is on the periodic table, so fastest finger and accurate. Fast and accurate. Okay, 10 more seconds. Anyone else still joining? All good? Okay, I think I can start now. Okay, already, Let's go. You can refer to the periodic table if you need to, or just make a guess. Well, you're sure you all know or not? AU. Wow. You all know your goal so well. How do you all even know? Great job. Okay, let's see who is the first. Joe, Bob, Ethan. Very good, very good. We have a lot of close competitor. Okay, let's see who can maintain the first few. What's the chemical symbol for cobalt? Be careful here. What did I say just now? I hope nobody choose Cobb. It's like a person's name, Cobb. There's no three letters. I see. So those who were not listening to me just now, okay. Cobalt is one element, so it's not the one in blue where we have C and O both in the upper case. Okay, so that is wrong. The O must be the lower case. The uppercase one, CO is carbon monoxide. C and O, carbon and oxygen. Okay. Great. Oh, we have a list. We have a change in list. RC, Kit Han, Joe, Kin, and Travis. Very good. Keep it up, huh? True or false? It should be very fast. I think you have no time to look at the periodic table. You must be fast. Very good. Hey, how? No, most of you know this, huh? Very good, very good. Wow, Kit Han is doing very well. Joe also, Travis. These three names constantly at the top. Let's go. Which element is the lightest? Oh no, helium is not the lightest. Hydrogen, okay, I know maybe you all choose helium because of helium balloon or something, but it's not the lightest. Okay, hydrogen is the lightest. It's the number one that is at the top, standalone one. Okay, so hydrogen is the lightest. Oh no, all changed. So we have now AL, JE. Oh, I can remove participant. Who wants to be removed? Okay, let's move on. Which element is in group 1, period 5? Okay, be careful here. Look at the periodic table, guys. Oh, that's pretty good. Great. 31 of you were listening to me. Or you're a bit more careful. Some of you maybe you guess and you guess it's cesium. Okay, rubidium and cesium, they are both in group 1. The rest are not. Okay, very good. Okay, Val and AL are still at the top. Just a few more questions, so make sure you score the last few. Okay, this one you need to slide a little bit. Just now, what did I say at the start? You can slide to that particular number. Slide to that particular number, Wow, we have a lot of different answers. Very good. Just now I said 118. There are some who give 126, 124. Okay, but most of you choose 118. Good. 34 of you chose that. Right. Ah, that's good. AL. What a nice name, AL. Okay, let's move on. Which element is known for its use in batteries? When you use battery, you always call it what battery? Like the laptop. What kind of battery does it use? Lithium. Yes, most of you got it right. Okay, we always use most of the time we use lithium battery. That's the most commonly used now. Great. Oh, AI is still at the top. Looks like AI is winning, So make sure you get full marks. Okay, this is the last 8 out of 10 question. So three more. Yes. Some of you will have learned, right? Actually, most of you, I think you all know this, like tungsten. Tungsten is the one that is used in which part of the light bulb? Filament, right? Okay, the one that glows. Okay, the filament is made of tungsten. Well done. Good. Wow, AL. Fantastic. We will need to take AL soon. Which element occupies 78% of the air? Wow, 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 wow. It's not very fast. What is the air mostly made out of? Good. Nitrogen. Most of you got it right. Not oxygen. Oxygen is the second most abundant. Oxygen is only 21%. Okay? Far below nitrogen. Good job. Oh, by AL. Okay, HB. Homer booster. Let's go. Okay, last question. Which element can you melt in your hands? See how well you all know. Gallium. Okay. Gallium is a solid at room temperature, but when we hold it in our hands, because our body temperature is around 37 degrees Celsius, it will go past its melting point and melt in our hands. Okay? So this difficult question. That's why it's the last question. Okay, so that's gallium. Good. Okay, let's see who won. No prizes here, just your acknowledgement. Val, very good. Hey, L, you're back. I clap for you. Yeah, good job. And who's the top? Wen good job. Okay, well done, guys. And HB, Kaden. Okay, let me go back to the question. Thanks for participating, guys. I hope it was fun. I hope. Okay, let's go back and hold on. Hmm. Let me see. Okay, come. Next part is compounds and mixtures. Now we have learned about elements already. So elements, just now we have learned that it is the simplest form of an element, simplest form of a substance, right? That's the first thing that we mentioned. Okay, simplest form of a substance or a metal. That's an element. But we can have two of these elements that combine together. Okay, or maybe even more. So just now one of you mentioned, right? You think that sodium is a salt. But sodium is an element, a salt is not. So if I combine sodium with chlorine, it forms so it will form it will form sodium chloride. And sodium chloride is the compound. So that is because sodium and chlorine, they will chemically combine together and form what we call the sodium chloride. And you are familiar with this. Some of you are familiar with sodium chloride. This is a salt that we eat. Okay, so sodium is an element, chlorine is an element. They join together chemically to form sodium chloride, which is a totally new substance. Okay, so this is E element, it becomes a compound. Okay, after a chemical reaction. There can be two or more elements. Okay, this is just the most basic one. Two elements join together chemically to form a compound. And each of these compounds has a chemical formula. That formula can tell us which elements are there and what is the ratio. So some of you might be familiar, like carbon dioxide, water, even sodium chloride. Okay, let me just put in here another one, sodium chloride, since we were talking about it. So sodium chloride. So this is NaCl. Can you just put it there? So Na ratio to Cl is 1:1. Can you just write this down? Just change this a little bit. Sodium chloride. Okay. So water, H2O, you should be quite familiar with that. H2O is 2:1. carbon dioxide, carbon is 1, oxygen is 2, CO2. Okay, so from the formula itself, we have the ratio. Okay? Okay, make sure you write down this sodium chloride as well. All right. Now let's move on. So just to recap again very briefly, compounds is also a compound is also a pure substance when two or more elements chemically combine. But what happens when we have all these elements that mix together, but they don't react? There is no chemical reaction. You just mix them together. They are just mixed together by physical means. It's just like you put sand and salt and sugar all together. Nothing happens between them. We are just mixing them all together. That is what we call a mixture. Okay, they are not chemically combined. So basically, if they are chemically combined, it's a compound. If they are not, it's a mixture. Okay, next. So some examples of mixtures. Air. Now you know that air contains nitrogen, oxygen. Just now we said, right? Nitrogen is 78%. I said the oxygen is 21%. Okay, and so on. So it contains all these different elements and even compounds together. So carbon dioxide is a compound. Water vapor is a compound. So air has elements, it has compounds all mixed together. Okay? So a mixture can consist of elements, it can consist of compounds, or both elements and compounds. For example, air. Okay? Now, if you look at salt solution and sugar solution, basically, salt solution and sugar solution, you add the salt, you add water to the salt, you add water to the sugar. So a solution, when we call it a solution, is already a mixture. They are mixed with water. Okay? Steel. Now, steel is very important, and always students will make mistake here. Okay, you may think that steel and iron are similar, but steel is a mixture. Iron a is an element. Okay, even though both are magnetic, that is because steel contains iron. Okay, steel contains iron, making it magnetic as well. Okay, so iron is part of steel. Steel is a mixture. All right. Okay, let's just put some ticks here. Classify these uh substances according to whether they are compounds or mixture. So can you all tell me in the chat now? Air is a compound or mixture? Air is a compound or mixture? Air, Rishi, air. Just now I just said it. No, no, no. It cannot be both. Okay, it cannot be both. It's only one. Air, right? So you come back here. Air contains nitrogen, oxygen, carbon dioxide. It's a mixture of all these gases. Okay, so air is a mixture. A salt solution. What about a salt solution? Salt solution contains sodium chloride and water. They are mixed together. There are no chemical reactions between them. You just dissolve the salt in water. Dissolving is not a chemical reaction, huh? So that's a mixture. Okay? But the salt itself, sodium chloride, without the water, is pure. Okay? When we add water to it, it becomes impure, not pure. Okay? So the salt itself is a compound. Until we add the water in, it becomes a mixture. And steel, just like I mentioned, is a mixture. What about water? Water has a formula H2O. Okay, so as long as they have a formula, right, that means they are a compound. Like sodium chloride is NaCl. Okay, as long as they have a formula, they are compound. Okay, so water is H2O, is a compound. All right. Any questions here? Okay, if not, I'm going to move on to separation techniques. Okay, so we have learned about elements, compounds, and mixture, some of the introduction to this topic. Now, how do I separate the mixture? Now, maybe I say, for example, I have air. I have some of these substances mixed together. But how do I get the nitrogen out? How do I get the oxygen out of that mixture? Okay, they need to go through these techniques called separation techniques. Basically, the name says itself, right? It's a technique to separate the mixtures. Okay, because these mixtures, these substances in the mixture, they are just physically mixed together. Means you add the sand, salt, and sugar together. How do I separate them? Okay, so separation technique will only work for those that are mixtures that you can easily remove them. Let's say, for example, I have iron and sulfur. And one thing we know about iron is that iron is magnetic, right? I can easily use a magnet, extract the iron out, and I have separate them. Okay, assuming that what is being, okay, because sulfur is not supposed to be magnetic. Okay, only the iron will be attracted by the magnet. So from there, on the magnet we have all the iron, and what is left in the dish will be the sulfur. So we have successfully separated them. All right. Next, filtration. Now for filtration, we use filtration to separate an insoluble solid from a liquid. Insoluble means that does not dissolve in water. Okay, so we have a solid that does not dissolve in water, and we want to separate it from a liquid. Okay, let's say for example, the easiest one, sand. Sand cannot dissolve in water, right? Sand is at the beach. If the sand dissolves in water, there's no beach. Okay, so we have the sand and water. Now, how do I separate the sand and water? So I just let it pass through this. Okay, actually, basically filtration, this technique is not just used in the science lab. It's used everywhere, right? Okay, we have filtration in the vacuum cleaner. We have filtration. Maybe you want to make coffee. Your parents make coffee. There's a filtration also involved. Okay, even if you go to the beach, you only want the sand in your hands. So what do? You scoop the sand up, the sand and water, and the water drips down. That's also kind of like a filtration. Maybe not the best, but you are letting the water drip away, flow out, while you have the drier sand on your hand. Okay, so that is what this technique is all about, filtration. We want to filter the sand and water. Okay, but scientifically in the science lab, what we use is this thing called a filter funnel. Okay, and we put a piece of paper on the filter funnel. This paper is called a filter paper. Okay, and we pour the sand and water onto the paper, which is lined on the filter funnel. So water will flow through the funnel and collected in the beaker, while the sand will be left behind. So when it passes through, we call it the filtrate. When it is left behind on the filter paper, we call it the residue. Okay? So this works for a mixture that contains a liquid like water and an insoluble solid that does not dissolve in the water, such as sand. Okay? Now, let me ask you a question. Can I separate sugar and water using filtration? Can you put your answer in the chat? Can I separate sugar and water using filtration? Okay. I have no, I have yes. Great. Most of you got it correct. Right. Not only if the sugar has not dissolved. Okay, okay, makes sense. Correct, Rishi. Right. You must know that sugar can dissolve. Sugar can dissolve in water. So if I mix sugar and water, highly likely is that the sugar has dissolved in the water, or at least part of it will have dissolved. So technically, I can't really separate them because the sugar has dissolved and it becomes a sugar solution. Sugar solution is just going to pass through the filter paper because there's no solid left behind. Of course, unless there are still some sugars that are not dissolved, okay, then yes, I can separate some of them. Okay, but the water that we get is not pure. It's still partially, it still contains some sugar that has dissolved. Okay, so it's not like I can separate purely to get sugar and water. Okay, it's not like sand and water. If I let the sand, uh, if I let the sand and water go through the filter paper, the sand will definitely be stuck as a residue. All right. Okay. So all these I have mentioned, right? So we can use it in vacuum cleaner, coffee filters. Okay, so these are things that we always use in our daily life. Of course, there are many other types. Okay. Okay. So let's answer these questions. Okay, one of you is asking, is the filtrate clean enough to drink? That depends. That depends. Now, in order to get drinkable water, okay, because you must know, right, this water, okay, let's say I get this sand and water from maybe the river or the pond, whichever. Okay, and the water is not the cleaner, right? So the water may contain some bacteria, it may contain I don't know, let's say some bacteria, some microorganisms. So I can do this, and yes, I can separate the sand and water, but this water will still contain the microorganism, and therefore it is not safe to drink. But if we are just talking about just purely water and sand, and then yes, this water is possible to drink. It's possible if this is clean water mixed with the sand, because all the sand will be trapped. But that's assuming the sand is clean. So there's a lot of things to consider, right? If the sand is not clean, then when it's mixed with the water, there are some bacteria, some microorganisms, then the water becomes unsafe. Okay, so generally, filtration does not produce a clean water that is drinkable. Okay, that's the general idea. Okay, let's do these questions before we move on to physics when teacher Ashini will take over. So let's explain. This is an explanation question. So it's not just tick only. You need to write a sentence. So explain why filtration is used to separate sand from a mixture of sand and water. So what is the science concept, that allows this separation to occur? What property must the sand have? That's what I'm looking for. Same thing for B. What is the property that maybe the iron and the sand have? Just telling me solid is not good enough. What about that solid? Just now, the example, I give you sugar and water. Sugar is a solid. But what about that sugar that allows it to, uh, that we cannot use filtration to separate them? Okay? So sand and sugar are, okay, undissolvable or insoluble. Insoluble is the term that we use. Okay? So insoluble is what we are looking for. All right? So thanks for trying that. That's good. So you can write that sand is insoluble in water. Okay, mention that it's in water. Okay, we don't need to talk about definite shape here. That is not required. You just need to say that it's insoluble in water. Yes, you can say it's a solid. Okay, that is insoluble in water. So it can be trapped on the filter paper. Okay, this is the answer. Okay, copy this. So sand is insoluble in water, and because it's insoluble in water, it can be trapped on the filter paper. It does not dissolve. Okay, instead of insoluble, if you want to say that it does not dissolve in water, also can. Let me just put a note here. Insoluble does not dissolve in water. Oops. What about the second one? Okay, Rishi asking why use paper for filtration? Very good question. What do you suggest? Okay, so we need some properties for the filtration to work, right? So first thing is it allows water to pass through. So we need a material to allow water to pass through. So things like plastic, all this cannot work. And we do not want the paper to maybe tear easily. So this paper is not the usual like worksheet paper. Filter paper, it has a slightly different texture. It's not the usual kind of paper where it tears easily when it's wet. So filter paper is a bit more tough, more durable. Metal does not allow water to pass through, right? I need the water to pass through, right? So it needs to be a material. So it can be like, maybe you can use a cloth, but in a science lab, we don't use cloth. So in the science lab, we use this particular filter paper. Okay, a cloth is something maybe like we if you go those drink store, they make coffee, they use a cloth filter, right? So that's also a filter. Okay, but in the science lab, we use filter paper. We don't use cloth. Because these are disposable. These are disposable. The wire gauze, the gaps are too big. So if let's say I want to separate sand and water, some of the sand will pass through, right? But filter paper, the papers are very fine. It doesn't allow small particles to pass through, but still allow the liquid or water particles to pass through. Okay, wire gauze, the gaps are still quite big. Okay, so that is not possible. Okay, second one, nobody has answered. Why can we use magnetic attraction to separate iron filings? Iron filing is very, very fine iron pieces, okay, from sand. So why can we do that? See, magnetic attraction is used to separate magnetic materials from non-magnetic materials. And all of you should know that iron is magnetic. Okay? Or you can say that iron can be attracted. The iron filings can be attracted, okay, by the magnet, but the sand cannot. Okay. Okay, so because one is magnetic, one is not, then you can separate them. Or you can say sand is non-magnetic, yes. Good question, Rishi. That is something that nobody has asked me before. but it's really interesting. Um, how are commercial magnets made? This one I'll have no idea too. I have no idea. Maybe I can Google that for you later. Okay. Any questions? Any more questions before we move on to the physics part? Teacher Hashini, are you ready? Okay, I think I'll pass the time to Teacher Hashini to take over the part on physics. Thank you.
Hello. Are you all okay after the chemistry part? Anyone not surviving anymore? Okay, so, oh, okay, got me already. Okay, so we have 1 more hour to go, so I hope all of y'all can get through this. You're alive, thank you so much. Okay, so what do I need you to have? Calculator, protractor, ruler, and pencil. So if you don't have any of these, you can quickly go and grab it. Let me share my screen. Okay, so today we'll be going through mainly density and refraction of light. So for the first part, let's start off. Wait, let me share screen again. Okay.
Some of the best opportunities to learn are the moments in which we are perplexed, those moments in which you begin to wonder and question. These moments have happened throughout history and have led to some truly amazing discoveries. Take this story, for example. There once was a fellow named Archimedes. He was born in 287 BC in the city of Syracuse in Sicily. He was a Greek mathematician, physicist, engineer, inventor, and astronomer. One day, Archimedes was summoned by the king of Sicily to investigate if he had been cheated by a goldsmith. The king said he had given a goldsmith the exact amount of gold needed to make a crown. However, when the crown was ready, the king suspected that the goldsmith cheated and slipped some silver into the crown, keeping some of the gold for himself. The king asked Archimedes to solve the problem, but there was a catch. He couldn't do any damage to the crown. One day, while taking his bath, Archimedes noticed that the water level in the bathtub rose and overflowed as he immersed himself into the tub. He suddenly realized that how much water was displaced depended on how much of his body was immersed. This discovery excited him so much that he jumped out of the tub and ran through the streets naked, shouting, "Eureka!" which comes from the ancient Greek meaning, "I've found it!" What did he find? Well, he found a way to solve the king's problem. You see, Archimedes needed to check the crown's density to see if it was the same as the density of pure gold. Density is a measure of an object's mass divided by its volume. Pure gold is very dense, while silver is less dense. So if there was silver in the crown, it would be less dense than if it were made of pure gold. But no matter what it was made of, the crown would be the same shape, which means the same volume. So if Archimedes could measure the mass of the crown first, and then measure its volume, he could find out how dense it was. But it is not easy to measure a crown's volume. It has an irregular shape that's different from a simple box or ball. You can't measure its sides and multiply like you might for other shapes. The solution, Archimedes realized, was to give the crown a bath. By placing it in water and seeing how much water was displaced, he could measure the volume. Then he'd calculate the density of the crown. If the crown was less dense than pure gold, then the goldsmith most definitely cheated the king. When Archimedes went back to the king and did his test, the story says, he found that the goldsmith had indeed cheated the king and slipped some silver in. These days, using the way an object displaces water to measure volume is called Archimedes' principle. The next time you take a bath, you can see Archimedes' principle in action. And maybe you'll have a genius idea of your own.
Okay, so based on this video, what do you think the crown with gold and silver is called? So just now, based on what Mr. Chu said, do you think it's a compound or a mixture? Okay, because there was both silver and gold, right? Do you think it's a pure substance? What do you think? It's a mixture, good Rishi, correct. So since it's a mixture, the density was different from the original gold. So if the crown was completely gold, then it should have been a different density. So let's take a look at what density is. So this is the formula that you need to know. So density is the mass per unit volume of a substance. And usually for mass, in this case, will be kg, and for volume will be meter cube. But you do have to take note of the units based on the question, based on what is given in the question as well. So what you have learned so far, a compound will be a pure substance, and you should know that it has a fixed density. And usually we use water as a way to compare whether something is less dense or denser. So water has a density of 1 gram per cm cube. So what do you think will happen if I was to add salt to this water now? So if you have salt water, do you think the density will increase or decrease? Here you can drop your answer. What do you think? If I add salt to water, will it be more than 1 gram per cm cube or less? Increase. Okay, so why do you think it will increase though? What changed? Okay, you're correct to say that the density will increase, but what happened? Isn't the volume of water still the same? You're adding. Okay, salt is dense. Reason? The mass. Yes, very good. So what is happening is that as you add salt, you are actually causing the mass, okay, to increase. And this will cause the density to be more than 1 gram per cm cube. Okay, so based on what you add to water, the density will also change because salt water is technically a mixture. Okay, so that is the basic principle you have to know and the formula for density. Okay, so moving on. So if something is placed in water and if the density is less than 1 gram per cm cube, okay, it is going to float. And if it is more than 1 gram per cm cube, it is going to sink. So that is your comparison to see if something will sink or float. But of course, you do have to take note if the medium is still water. If it's not water, then you have to take a look at what is the medium and check whether the object will sink or float, respectively. Okay? Okay, any questions so far? So I need you to know the formula and to be able to compare and check if something will float or sink. Okay, so based on that, can we try question 5 first? Okay, for 5a, do take note you have a cube of length 2 cm, and the formula that I need you to know will be density is equals to mass over volume. Okay, I already told you that it should be gram per cm cube, so you don't have to change anything. But the cube is in cm. How do I get to cm cube? Okay, what do you think I could do? Or if you have done it, you can drop your answers in the chat. No one has an answer yet. 2 times 2 times 2. Oh, Jing. Okay, so why must you do that though? What are you trying to find when you do 2 times 2 times 2? Correct. So in this case, since you have the cube of the length, which is 2, you should be able to find the volume first. Okay, so 2 times 2 times 2. Okay, your length times breadth times height. Okay, and then your answer, 8 cm cube. Okay, and they already gave you your mass as well. So how do you find your density? Okay, anyone has an answer for density? So you have volume and you have mass. So what should be the final answer for your density? Okay, I have some answers coming in. Valerie, 0.8. 1.25. Iris, how do you get 1.25 though? I think you swapped the numbers. Okay, 0.8, 0.8. But are you missing something? Okay, so it should be mass, which is 6.4 divided by 8. Okay, for those who did 8 divided by 6.4, please be careful. You're not supposed to do that. Okay, you need to follow the numerator and denominator quite strictly. Okay, and you should get 0.8. So if you have this as your answer, you are there but not there. What are you missing? Something very important. Yes, so please make sure you have units. Very important. No units, no marks. Okay, please do not lose your marks unnecessarily. Okay, units. Very important. Okay, please make sure you have your units. Okay, so this is your answer for part A. Okay, if you are ready, you can try part B. Now you have a liquid with a certain density, and you have to calculate the mass when you have 250 cm cube of liquid X. So same formula, density is equals to mass over volume. Okay, if you have gotten your answers, you can drop it in the chat first. We need to find mass. Okay, density is given, so 0.78. Mass is what we need to find, and volume is 250. Okay, what would be your answer? Okay, what do you think you have to do? Okay, I first answer 195 grams. Iris, what's with the question mark? What happened? Are you not sure? 195 grams, okay. Anyone else has any different answers? Rishi also 195. Okay, that's good. Okay, so in this case, 0.78, you have to multiply it by 250 to get 195. Can you stop here? Okay, very good. All those who gave their answers gave their units as well. Really good job. Okay, please make sure you have your units. No units for marks. Okay, so for all your calculation questions, please show your calculations clearly. And most importantly, the units have to be there. Okay, so now you have the cube and you have density. They're asking you if the cube is going to float or sink in liquid X. What do you think? So if you were to compare cube, the density was 0.8 gram per cm cube. This was from A. And then the liquid X is 0.78 gram per cm cube. From part B, this is already given right here. So if I was to place the cube into X, so if we have a container full of X, and if I put the cube in, what do you think is going to happen? Okay, float or sink. So just now I told you if it's more than 1 in water, it should. Okay, we have a few answers coming in. Okay, you can go up and check here as well. Floating or sinking, is it less dense or denser? Check the number. Okay, it will sink, it will sink. Okay, but what's the reason that it will sink? Okay, what will be your explanation for that? Because they ask you to explain your answer, so you cannot stop here. And you don't have to take one. Secondary school, no more half mark. Okay, but PSLE already don't have, but there will be completely no more half marks. So please make sure that you answer completely. Cube is denser than X, more than a specific weight. Okay, Rishi, for weight, mass and weight are two different things. So you can't use the word weight. You will learn more in Set 3, but please stick to the word mass. Okay, so we have Iris cube is denser than X, correct? It will sink because the cube's density is higher than liquid X. Okay, because 0.8 is higher than 0.78, as a result, you are going to have the cube's density higher than liquid X. Okay, so this should be the answer for part C. The mass of the cube is greater than liquid X here. Yes, as what Mr. Chu said, you cannot compare the mass. You have to compare the entire thing, which is density. Because we are looking at mass divided by volume, not only mass or not only volume. Both the factors will affect density. Okay, Kat, is everyone okay? Any questions so far? Okay, can I move on? If you have not copied, you can take a quick picture. Okay, moving on to the next one, which is light. So this is the end of density. So just a quick summary. What I need to know, only the formula, and to be able to compare if something will float or sink in a medium based on the density of the medium as well. Okay, and please do not forget your units. Okay, next one. Reflection and refraction of light. Okay, how is this different from what you have learned so far? Is that you have to know what's the difference between these two, and you must be able to draw diagrams. Okay, light is one chapter where you will need your pencil, ruler, reflector, everything back. Okay, there'll be a lot of calculations in science, a lot of drawing in science as well. Okay. Okay, so for the first part, reflection. Reflection is just the bouncing of light off the surface. So this one you should have learned it in primary school as well, where when you have light hitting a surface, it will be reflected off. So basically you have something that's coming in and exiting as well. So the ray that comes in, as you can see, the word incident, okay, this is the in, and what is being reflected will be the exit ray. Is there a connection between angles and the light for this chapter? Yes, you must be able to apply some math concepts for this, but for today it will be quite simple, so you don't have to worry about that. Okay, and the angle between your incident ray and normal. So what is a normal here? You can take a look. It's a perpendicular line at a reflecting surface. And please take note, you can see that it's dotted, right? Every single time you have a ray diagram or light diagrams related to light to be drawn, you must make sure that it's always dotted. Okay, because this is just an imaginary line and it's not really there or something that you can see as well. Okay, so the incident ray and reflected ray will be in bolded lines and your normal should be in imaginary line or should be dotted. Okay, the point where it hits the surface will be called a point of incidence. Okay, so this point right here is your point of incidence. And the angle between your normal and your incident ray will be angle of incidence. So you'll be denoting this with a lowercase I. Okay, and then the other side, the angle between the normal and the reflected ray will be denoted by a small r. Okay, so why do you need to know this I and R here at the moment? Oh, okay, question. What if the surface is not even? Okay, in this case, reflection will still happen, but I and R may not be the same. How do you draw the normal line? Oh, you don't have to know how to draw ray diagrams for uneven surfaces. Okay, so we will just stick to even surfaces only. Okay, so don't worry about that. Okay, so one important thing that I want you to know is that every single time there's reflection, your I and R will always be the same. Okay, so in this case, please take note that when you have a incident ray that is hitting the surface, there will be a reflected ray. And please take note that your surfaces have to be smooth from what you have learned so far. So, and you will not be learning the uneven part. Okay, so you must know that I and R will be the same every single time that reflection happens. Okay, anyone got any questions so far? Oh, okay, everyone's surviving. Okay, the important thing here is that you have to know that I and R will be the same. Okay, so moving on. Okay, so we have question 6 where you have to draw the single light ray and you have to tell me how it's reflected, indicating the normal and the angle. So you can see that this is 2 marks, easy 2 marks to score. So the science we split in Sec 1. What do you mean by really be split? Or you mean like bio, chem, and physics, is it? Is that what you mean, Nico? If that's what you mean, yes. But you'll be learning it. Depends on the school. Some schools actually do it biochem and physics. Some is quite mixed depending on the textbook as well. Okay, so it really depends. Okay, for the rest, can I get you to try this? What's the first thing that you always have to do will be to draw normal. Okay, so for the normal, please take note, dotted. Please use a ruler. I don't have a ruler here online. Okay, so normal should be somewhere here. Okay, all my drawing estimations, please make sure you use a ruler and make sure you use a pencil to draw a straight line. The point at which your incident ray, this is your incident ray. How do you know it's an incident ray? Look at the arrow. It's pointing towards the mirror. That means it's coming in. So in this case, you have your normal dotted line. So that's your first mark. Okay, so it is an opposite angle that is equal to the first line in the middle. Yes, so normal is in the middle. And then I want everyone to go and get your projector. Measure this angle right here. Okay, measure the angle. Okay, and can you tell me what is the angle there? Did anyone measure? Have you gotten your protractor? Do you all remember how to measure? I hope so. I hope all of us do remember how to measure. Okay, we need to measure the angle here. Here, let's do grabbing your protractor. 87. Isn't that a bit too big for a small angle? Braden. Okay, I want a small one right here. Okay, it's an acute angle, so your answer should be less than 90. Anyone else has an answer? Okay, when you draw your normal, please make sure it's 90 degrees to the mirror. Okay, this is just an estimation, but yours should be 90 degrees. Okay, 90 degrees to surface. Not sure where your protractor is. Okay, those who have a protractor, Rishi can take a smart guess. What do you think? After PSLE, all of you have thrown everything away, is it? You all still need a projector, ruler, and pencil for secondary school as well. 40. Okay. 25. Okay. Alicia got it. 25. Okay, so what I need you to do is that we are going to draw the ray that is going to be exiting, okay, on the other side, which is your reflected ray. Okay, mine is not 25, but please make sure yours is. Okay, so you have to measure. Okay, this is just estimation. Measure such that this angle right here, the purple one, has to be 25 as well. Okay, the purple one is 25. The biggest mistake that a lot of students do is that they measure this part to be 25. No, the angle should be in the middle. Okay, in the middle of the normal and the ray. Okay, not to the surface, nothing to do with the mirror. Okay, this has to be 25. And when you're ready, please put your ruler there and draw a solid line with your arrow head out. Okay, normal, then the angle, because we went through that I is equals to R, right? So that's why 25 at the red part will also be 25 at the purple part as well. Okay, and then you draw your reflected ray. And very important, please make sure you have your arrow head. Okay, anyone here manage to get this, or anyone need me to repeat? Okay, let me redraw this part. Please make sure only your normal has to be dotted. The incident ray and your reflected ray have to be solid. Okay, and in this case, please make sure you label your angle 25 as well, because you have to show me the incident angle and your point of reflected angle will both be the same. And please draw a solid line and arrow head up. Okay? Can anyone has any questions so far? hope all of you are using pencil and a ruler. Okay, even for those who don't have a protractor, please try to estimate about 25, around there. Okay, but please make sure the most accurate answer has to be done using a protractor. Okay? Okay, moving on. Okay, next one, refraction. So you have seen reflection. Reflection is when light is being bounced off. But what is refraction? Okay, let's take a look at the second video first. Oh, magic. Where did the coin go? Okay, can you see actually the coin is right there, but what happened? Why did the coin disappear? Okay, please think about that, okay? Okay, so at this point, what do you think happened? If you were to take a look at the coin from the top, so that's why they have the plate. So if you take a look from the top, you should still be able to see the coin. But what is happening here? From the side, what has happened? Why did the coin disappear? The coin is still there. Don't tell me the cup swallowed it, not possible. Okay, but what happened? Okay, what do you think? Refraction. Okay, so what was changing here? Okay, the way you look at it is one thing, but because of the way you look at it has changed. Refraction has happened. Okay, so what is refraction? So cool, right? The coin suddenly disappear. But when you change the way you look at it, it's going to appear again. So as a result, this is very important because you need to know that it is the bending of light. Okay, refraction is the bending of light. So just now, reflection we saw was just the bouncing off D. Okay, bouncing off of light. So if when it hits the surface, a mirror or any object that can allow light to be reflected is going to bounce off. But refraction is going to be bending of light, and the reason why this happens is because different optical density. So what does this mean? So when light passes through air, it has a different speed. When light passes through glass, what do you think is going to happen? When light passes through water, do you think it's going to be the same speed? Okay, as it passes through different medium, the speed is going to change. As a result, light is going to bend. Because your reflection is going to happen in the same surface. Don't tell me your mirror is half water, half in air, right? It's going to be completely in air. So when you look at yourself, it's just going to be a reflection. But if you have a change in medium now, what is going to happen is that there's a change in speed. And as a result, you are going to have the light to bend. Okay? Okay, so in this case, okay, you can take a look at the fact that air has the fastest speed, okay? And as it goes down the table, you can see that ice, glass, and water, the speed is slowly decreasing. Okay, speed is decreasing. But why do you think speed is decreasing? What was the factor that's affecting the speed? Okay, what do you think? I just said it just now. Okay, what affects speed? The blockage. What does the blockage of item means? What do you mean? What is being blocked? Okay, items blocking light. If items block light, that is opaque, right? So as a result, what's going to happen? You're going to form a shadow. In this case, light should be able to pass through all these mediums though. Okay, let's go up again. What is going to affect here? What is going to affect your refraction is when you have different optical density. Okay, so in this case, all these medium here have different optical density. Okay, the optical density will also be indicated with a letter n, okay, a lowercase n. So if you see me using this lowercase n, it means that it's optical density. Okay, so you can see that speed is actually decreasing in all these medium. So what do you think is happening to the n? N value increase or decrease? So is your optical density increasing or is your optical density decreasing? Okay, the answer is right below. Okay, it should be decreasing. Is it when speed increase? Okay, when it is going slower and slower, what is happening to the optical density? Okay, the answer to this question is right below this table. Okay, please take a look. What is going to happen as your light slows down? Okay, no one has an answer. That's so sad. Hello, hello. The answer is right here. Okay, so what do you think now? Okay, I've given you the answer also. Okay, in a medium, when your speed decreases, okay, the higher the optical density. All right, thank you. Who's this? Josh, thank you so much. Okay, so when the speed decreases, it means that your optical density is increasing. So if optical density is increasing, you can take it that, let's say the light is passing through a forest. If there's lesser trees, it's easier to pass through, so it's faster. But if the forest is packed with trees, then you're going to take a longer time to pass through the forest, right? So as a result, the speed of light will be slower. Okay, so that is the analogy that you can use to compare. Okay, so when light passes through from air to glass, so air will be less dense. Okay, that means the optical density is lower than glass, which is denser. So in this case, the optical density is increasing from air to glass. If optical density increase, it's a forest with a lot of trees. Am I going to go slower or faster? Okay, what do you think? Slower or faster? If we have 30 minutes, y'all become too tired. Are y'all okay? No answer. Well, how come you're not enthusiastic for physics? Y'all were so enthusiastic just now for Mr. Chu's one, right? Wow, I'm sad and I'm hurt there. Hello. Okay, light moves through. Can I sleep? I also want to sleep, but can you get through with me for 32 minutes? Can after this we are crashing, okay? But 32 minutes more to go. Okay, will light go faster? Hopefully, I'm hoping as well. Okay. I know it's tough, 9:30, holiday mood. I'm also in my holiday mood, so let's get through this first. Okay, light will slow down. Okay, some said faster, some said slower. Or what does n represent? N is optical density. Okay, I'm just using n to make it easier for you to understand. Okay, so the light will slow down. Yes, from less dense to dense is a forest filled with trees. So in this case, it should be slower. And what is going to happen is that your light ray is going to bend, but towards the normal. So how do you know if something is towards or away? So you can continue drawing the original light ray. So if it does not bend, the green one is the original light. But if it's towards the normal, you can see that it actually shifted closer to the normal. That's what it means. Okay, so towards the normal basically means closer to the normal. And please make sure you do not forget your rays arrow heads. Incident ray must be in. And in this case, it's refracted ray, not reflected. Okay, so this is from less dense to dense. Okay, so this is your first scenario. Anyone lost? Anyone already said to be here? Said also too bad. Please get through it, okay? Okay, next one. So what happens if it's the opposite? Now you have glass to air. So in this case, for glass will be denser, and for air will be less dense. So in this case, it is leaving. So from glass to air, your N or your optical density should be lower because air is now easier to flow through, easier to pass through. So what do you think is going to happen to the speed? Okay, is that okay? Okay, Nicole, will it increase? Or question mark? What do you think? No one else has an answer? Decrease? Okay, so think about the fact that the light is now passing through a forest with lesser trees. So is it easier or harder? Slower or faster? Not sure. Okay, faster. Yes, correct, Josh. So as a result, the speed will increase. So when your speed increases, what is going to happen? Okay, to your light is, firstly, let's draw the original ray first. So if the light was to continue passing through without bending, the green one will be the original one. Okay, faster increase, yes, correct. Okay, so as a result, if the speed is going to increase, the light ray is going to bend away from the normal. Okay, so you can see that it's moving away from the normal. Okay, so that will be the difference if it's the opposite. So how do you remember this, right? An easy acronym for you to remember. You can remember it as fast. Okay, so what does this mean is that when the speed of light is fast, what is going to happen is that it's going to move away from normal. Okay, and when the speed of light slows down, it is going to move towards the normal. Okay, so this is the acronym that you can remember. Okay, and think about whether the speed will increase or decrease first, and whether it should move closer to the normal or further away from the normal. Okay, that will be the two clues that you need in order for you to draw this ray diagram. Anyone lost so far? Everyone okay? Rishi, are you not okay or are you lost? Which one? Okay. How is the result of less dense to dense different from denser to less dense? What will you see? From less dense to dense. So from less dense to dense, that will be the first one that we saw, which was air to glass. Because in glass, the optical density is higher. As a result, the speed will decrease. So your light is actually traveling slower. So that's why your light will be bending. But for the opposite one, which we saw right here, this is when your speed of light is increasing. So it will still bend, but in the opposite direction. So the speed of light will change according to the optical density, and the direction in which your light ray moves will also be different. What would be the point of knowing an object's density? In this case, wow, such a profound question. In the future, if you decide to build a ship, you have to know if the ship is going to float on water and what's going to happen if it sinks. That is something you can think about. Because a ship is such a big object, right? But how is it able to float? Okay, that will be one point you can think about it. So both of the setup, you cannot see the coin. Which set? Oh, you mean the video? For both of the setup, there was only one setup though, where they had a cup with water and you were not able to see the coin once the water was poured in. If you see the coin from the top of the cup, you should still be able to see the coin. It's just that from the side, because of the way that the light is going to be refracted and the bending of the light, you won't be able to see it from the side. Okay, because the coin is still here, right? It's not that you won't be able to see it. It's just that from the angle in which is different. Okay? Okay, anyone else? Any other questions? So these are the two scenarios first. Okay, then the next one. So what's going to happen if light goes in straight? Okay, so you can see here that there's no normal. So all this while there's always been a normal, which is dotted and an imaginary line, and it's always there as a guidance for you to know how to draw the ray that's coming out. In this case, if your incident ray is 90 degrees in, okay, what's going to happen is that it's going to come out 90 degrees as well. So in this case, there will be no change, no refraction. Okay, because even when there's a change of optical density or change in the speed of light, because it's going along the normal, there will be no change in the direction of the light. Okay, so these are the three scenarios that you have to take note. Okay, but the best way to remember will be this acronym here. Then if it's 90 degrees in, you can remember that it's 90 degrees out. Can anyone lost? Okay, so these will be the three scenarios that to take note of. Can? Okay, if you are ready, we can move on to some real life application. So the opposite angles are equal. Opposite angles in refraction. You mean here? Okay, the opposite angles are equal. You mean the incident angle and the reflected angle will be equal. In refraction, they are not equal. So that will be here. For reflection, right here, angle of incidence is equal to angle of reflection. Okay, not for angle of refraction. Okay, two different things. Okay, so I is equals to R only in reflection, not in refraction. Okay, so in this case, you can also take a look that I here is definitely much larger than the R here. And in this case, the I is smaller than the R. Okay, angle of reflection will be the same, not refraction. Okay, we should hope that answers your question. Okay, moving on. Okay, so refraction is when objects will appear bent as well. So just now when you saw the cup with the coin, you couldn't even see the coin. But if you were to put in a pencil, if you look at it straight, okay, you can see that the coin actually looks bent, but it's still there, right? It looks like it's not aligned. But in this case, if you look from the top, it looks like it is bent. But actually, is the pencil misaligned or actually bent in real life? Okay, you're just going to put in a full length of pencil. And it's just that the way that the light enters the cup, okay, because this is air and inside here is water, as a result, when there's a change in your optical density, okay, and the way that your light bends, that is going to cause this kind of illusions actually. But actually, your pencil is completely fine, okay? It's nothing has happened to it. It's just that the way you see it will change the way that it looks. Okay? And as a result, why is this happening? Okay, so you can see here that this is the light rays that's coming from the original position of the object. Okay, this is the original position. Okay, and you can see that it's bending. But where you're gonna see will be here. Okay, this is what you see. And this is where the object originally is. So you can see that the way that the light bends has caused it to look very different, and especially the way that you are looking at it, is it from the top or is it from the side? Okay, will make it different as well. Okay, is everyone okay? So if you actually take a look into a swimming pool, right? Does it look shallower or deeper? Okay, when you all go swimming, and then it says like 1.6 meter. But if you look inside, does it actually look like 1.6 meter? Yes, Rishi, correct. It looks shallower. So what is the reason that it looks shallower? Okay, it's the same concept as here as well. So if you drop things into the swimming pool, or based on the depth of the swimming pool, okay, so that is going to cause a difference in the way that your light is going to travel. So there's going to be a bending of your light ray, and as a result, it is going to have a bit of a difference in the way you see it. Okay? Ollie, can you show us the angle of incidence, angle of refraction in the diagram? Diagram? Angle of incidence. Oh, you mean this diagram? The one that I am here right now. I'm talking about this one or the one on top? Ah, okay. So where do you think angle of incidence? In first, then out. Okay, so in this case, your light ray is actually traveling from water to air. Okay, so angle of incidence. So your two rays, and please make sure everything has to be with respect to the normal. Okay, so you have one angle here. I hope you can see. Another one here. Okay, then let me use here. The green one. Okay, and then you have blue one. So which one do you think is incident and which one do you think is refracted? Okay, I for incident and R for refracted. Okay, take a look at the direction of your arrowhead. Okay, so for all the diagrams that you have seen so far, the light has been coming in from the top, but in this case, it's coming in from the bottom. So which one do you think is I and which one do you think is R? Okay, anyone has an answer? Okay, incident ray should be in, refracted ray should be the one that is leaving. No one has an answer. That's so sad. Now ask Mr. Chu. Mr. Chu, what do you think?
Green one is the eye.
Okay, so in this case, okay, so this is a bit confusing. So this is the eye, this is the eye. Okay, then your blue ones are the R, which is refracted. So just take a look at the arrow. So if it's going in, so you can see that the arrowheads are leaving the water. So this will be incident. And you can see that it's bending once it enters the air. Okay, so once there's a change in your medium, there is going to be a bending of light ray, and that's when refraction happens. So take a look at where the light is coming from and where the bending happens. Okay, so your clues are always the arrowheads. Okay, so always take a look in and out. Okay, the one who asked this question was Ollie. I hope that answered your question. Okay, so let's move on. So just now, based on the swimming pool example I just told you right here, so objects will appear nearer to the water surface and swimming pools will also appear shallower. Okay, yes, it bends away from the normal, right? Okay, so if it is from water to air, this will be dense to less dense. So in this case, the speed is increasing. So if your speed is increasing, what is going to happen? If you take a look at the acronym right here, speed increase means away from the normal. So yes, correct. Okay, it should be away. Okay, so then your application will be the swimming pool. So you do have to be careful. Just because it looks shallow doesn't mean it's shallow. It's just the way that the light bends. As a result, it looks shallower. Okay, so always check the depth. Okay, so if everyone is ready, let's try the last question of the day. How can the speed of light be increased? Because the medium changes, the speed of light increases. So from glass to air, in air, it's easier for the light to travel as compared to in glass. So that's why the speed of light naturally increases. So it's something like when you're walking on flat surface, isn't it easier to walk as compared to when you're walking up here? So your speed also changes depending on how easy or hard it is to travel through the medium. Okay, that would be the easy, simple explanation for this. Okay, for the rest, you can try 7. Okay, how the optical density of medium affects how light travels through the medium. Okay, how will it change? Okay, you can type down your answer. Okay, or you can tell me which page you can find the answer as well. Okay, you can go up. The general relationship of how the optical density will change. The speed of light. So somewhere here. Okay, page 13. Okay, so what do you think is going to happen? So let me maybe start off first, then you can tell me how to complete. I have an answer. The greater the density, the slower the speed of light. Okay, you can't say greater the density, you must say optical density. Okay, because in this case, since it's related to light, the word optical density has to be there. Okay, so correct. The higher the optical density, so please make sure you write optical density of the medium. Okay, what is going to happen? The slower the speed of light. Okay, can, only can. Okay, anyone alternative answers? Slower or lower the speed, or speed of light decreases, also can. Okay, so this should be your answer for part A. Okay, so higher the optical density, slower or lower of the speed of light in the medium. Okay, so that should be your part A, which is just a general relationship of how the speed changes. Okay, then let's take a look at part B, optical density of air and glass. So based on what we know, the speed, we know that glass definitely has a higher optical density, so the N is definitely higher. So this is a forest with a lot of trees. So is it going to be slower or faster speed? Okay, slower. Okay, thank you. So as a result, if it's going to be slower, what is going to happen to optical density? Glass has higher optical density or air has a higher optical density? Okay, glass is going to be slower. So which one do you think has a higher optical density? Okay, anyone want to try? Okay, glass has fill in the blanks. Okay, what do you think? Optical density than air. Okay, anyone has the answer? So what do you think is the optical density of air? Is it higher or lower? Yeah, lower. Oh, I told you. That is denser than air. Okay, high. Okay. Nicole, does glass have a lower optical density? When will your speed decrease? Your speed will decrease when it is harder to pass through, right? So your optical density has to be... No, air has a lower density. Okay. So the answer here should be glass has a higher optical density, or what Nico said was also correct. Glass is optically denser than air is also correct. Okay, so you must tell me that it's optically denser, and please make sure you use the word optical density. Okay, that has to be there. Okay, then for part C, we went through it just now. How is the speed of light different? So in this case, okay, light travels in glass than air. The answer is right there. Okay, so glass is definitely harder to pass through. So in this case, slower. Okay, very good. Okay, so your light travels slower in glass than in air. Okay, so these will be answers for B and C. So based on this, now we have the last part. Okay, you have to draw the ray diagram, entering the glass and exiting into the air. So just now, the acronym that I went through, FAST. Okay, so if it's faster, away. If it's slower, it's going to be towards. So the first thing is that you can see that this is 3 marks. Very important. Please make sure you have your normal first. Draw normal. Normal must always be dotted. Please make sure you use a ruler. Okay, one thing about this ray diagram is that because the light ray is starting from air and ending and coming out from the glass back into air, you have to make sure that the first ray, which is this one, is parallel to the ray that we'll be drawing here. So we'll be drawing 3 rays in total. Okay? 1 and 3 have to be parallel to each other. So sometimes this can be a bit confusing. Maybe you want to draw 1 and 3 first, and then you can fill in 2. But if you're confident enough, you can go for 2 straight as well. But since we know that glass has higher optical density and is slower, is the light going to bend away or towards in this part? Okay, from air to glass, optical density is higher. So what is going to happen? Okay, you can also try drawing in first. Light bends towards, yes, correct, thank you. So bends towards. Okay, so from air to glass, you should bend towards. Then the opposite for glass to air, where it's away. Okay, so let me tell you that this is only an estimation, so please make sure yours is accurate enough. Okay, so every single time you draw your ray, please make sure you have a normal. Okay, ray here, and the ray that's going to come out has to be parallel. Okay, you can use your ruler and try to make it as parallel as possible. I hope mine is parallel enough. Okay, so in and out parallel because it's the same medium, but in the middle, as we have found out, towards. So what is towards? Okay, what you can do is that you can take out the original. Sorry, wait, let me check. Okay, please make sure yours is nicer, okay? Okay, parallel. Okay, then towards, you just have to make sure that it goes closer to the normal, and then you just connect your 2 normals, okay, as nicely as possible. Please make sure you use a ruler and pencil. Okay, mine is not as straight and nice. Okay, so please make sure your 1 and your 3, okay, the in and out parallel, and then in the middle, it just has to be closer to the normal. Okay, because it's moving towards the normal. Okay, this is how you draw your ray diagram. And important things to take note, you must make sure that you have your arrowhead to show the direction. And please make sure you have your normal. Your normal has to be dotted lines, okay? Because they're imaginary lines only. Okay, and the third mark goes to the first line and the third one being parallel. Okay, so you need to have parallel light rays. Okay, for 1 and 3 only. Did y'all manage to get this? Anyone lost? Okay, so for light, there'll be many questions that require you to draw, and you'll be learning even more complex drawing as well. So please try to make sure you score as much as possible for this drawing. Okay, so these simple things such as your arrowhead and normal will easily score you 2 marks. Okay, so make sure your direction is correct, your normal is dotted. Okay, and always take note, is it easier to travel through the medium or is it harder? And that will determine your speed and whether it's towards or away from the normal as well. Okay, anyone, any question? Okay, anyone need me to show any of the previous answers? Okay, if everyone is okay, this is the last part for today. I hope you all have learned something new and interesting and you're looking forward to entering Sec 1. Okay, not the other way around. I hope we have not scared you off.
I hope all of you are feeling okay. Now, don't be scared by all these. This is a brief introduction. So if let's say there are some parts that you feel that you are still not, you did not understand fully, don't worry. All right, when you learn it in school, in my stretcher, right, all this will be taught again and learn it properly that time. Okay? But otherwise, you can still put your questions here. Now, in the meantime, in case you are you are my stretcher students, okay, or you had joined us in our boot camps, right? Don't forget to submit your PSLE results, okay? Because if you did well for your PSLE, we want to award you. So this is the My Stretcher Achievement Awards, right? So you look at the money here, right? Is your eyes already opening up, right? Or you just woke up, is it? So if your score is 4 to 6, extremely well, extremely good, okay, you can get up to 300, you can get $300, okay? If not so well, okay, you get around 225, okay, but still a good amount, right? So this applies if you are my stretcher students at least till 31st August this year, or if you have joined us for our PSLE boot camps. Okay, even if you are non-my stretcher students, you're also eligible for these awards. Okay, so you can only receive one prize unless otherwise stated. So some of these, for the special awards, okay, if you can get award for your PSLE score. You can also get best progress or special achievement. Some of these you need nomination by the teacher, so you can ask your teacher for that. Okay, and you can also self-nominate yourself. Okay. If you have submitted already, very good. Okay, but if you have not, the due date is end of the year, which is 31st December. Don't miss that. Right before you do your countdown, make sure you go and press it. Make sure you go and scan go to this link and key in your score if it applies to you. Okay, I hope that all of you have done well. Right. Show question 5. Okay, we'll show the question 5 in a while. Okay, so I'll put this here for a while for those who have not submitted. Okay, you can the link is also shared in the chat. All right, for those who have your phone, you can scan the QR for if you have not submitted your score. Question 5 is it yours or mine? Question 5 is density, I think. Can you show your density part, Shini?
Oh, okay.
Right, so thanks all for joining. Okay, we'll just be answering some of your questions if you have. So you can stay behind and ask question or continue to put your question in the Q&A and chat. Okay, well, now we show question 5 because one of you have asked. Okay, otherwise, thanks. We actually come to the end of this session. Thanks for joining us. I hope this is give you a good introduction to what you will see in Sec 1. Okay, so thanks all for joining. Have a good break during the Christmas. Yes, we will show question 5 now. Yeah. So please have a good break. Okay, thanks for joining us. Thank you. Happy New Year, guys, and Merry Christmas.
Bye.
So question 5, yeah. You able to show?
I'm showing question 5.
Okay.
Can I see?
Yep.
Okay.
Albert, this is question 5. Any questions here, Albert? Or anyone else? Can we go? Yes, you may go already. Thank you. Thank you. Oh, Albert has left. Anyone else have questions? Anybody? Now, if you have not joined us for our Telegram community for secondary science, please do join us since you have now promoted from P6 to Sec 1. Okay, so those that are related to you will be all found in the secondary Telegram community chat. Okay, so do join us there. And for other MindStretcher events, you can look up in the Luma. The link has been put in the chats. Okay, if there are no further questions, then we'll end our session today. Thanks everyone for joining. Thanks, Teacher Ashini and Shei. Thank you.
Bye bye.
Bye.